Welcome to the Turning Points podcast. I'm Tim Chatton. I'm here with Tom Hoenig.
Hello.
And today we're going to cover ceramic bearings versus steel bearings and why you might choose ceramic over steel bearings. This podcast is going to cover a lot of topics, so we thought this would be a good one to start with. So, first off, what are ceramic bearings, for those that don't know?
Sure. Ceramic bearings, just to start, a lot of people think of their bearings made of ceramic, and while that's partly true, it's really the center, the ball in the raceway of the bearings that are the only ceramic component. Mm-hmm. The raceways, even though some of them can be hybrids, are still made of steel. So when we talk about a ceramic bearing, the real leading factor of what makes it a ceramic bearing is the ceramic silicone nitride balls that make up the bearing. And, you know, they obviously have some key points of improvement and advantages over steel.
So the bearing itself, is it all ceramic? Is it like a shell on top of a steel bearing? Or?
You have a standard steel, hardened steel inner raceway, mm-hmm. A standard hardened steel outer raceway. Usually the cage is of a phenolic substance that holds the balls in their track, and the silicone nitride, which is the ceramic, is what gives it the ceramic hybrid. Its name of ceramic ball bearing is the ceramic component of the bearing is in the balls. And because they are so light in comparison to mm-hmm. steel, you know, we have a little prop right here. Yeah. If we can show our audience real quick, I've got a steel ball and a ceramic ball from Surbeck, which is one of the leading producers of ceramic balls. And you can see the distinguishing two different colors.
Yep.
But you can also, if you hold them in your hand, one weighs phenomenally less than the other.
Yep.
I mean,
this one is
less than half the weight. Yeah. So if we take that into consideration, if something's going around in a circle very fast, that load of its weight is an extraordinary part of the like limiting speed of the bearing.
If you have free weights in your hand, you have like a 1 pounder or a 5 pounder, you're going to be able to swing your arm a lot faster. Yeah.
Exactly. So lightness of the bearing equals into direct speed increases of the bearing. And then we have some other props here which are kind of neat. If you look, we've got a ceramic ball and actually a steel ball. I'll hand them to you since you're the one who put them under the torch test.
Yeah, so this one we put under fire and flames and grinding, and this is the result of what used to be a nice shiny steel bearing.
Like that.
And the ceramic bearing looks brand new, and it went through the same kind of torture test, which is quite remarkable how that turns out.
Yeah, they're extraordinarily hard, you know, up to 12 times harder than a steel ball, which only equates to 10 to 15% more stiffness in the bearing, because we still have to equate that the inner and outer raceways are still steel.
Yeah, the raceway could still fail.
Exactly, but we've done some tests before too, where we take a ceramic ball and put it on an anvil and actually swing a hammer to it, and it dents the hammer in the anvil but does not dent the ball bearing. So hardness is another key factor. So putting that with its weight factor, and that it can be polished to such a tight tolerance over steel as well, reduces all that coefficient of skidding and everything else that makes a ceramic bearing be able to outproduce not only in its longevity of life, but the speed factor. We see sometimes 30 to 40% more speed out of a ceramic ball bearing than a steel.
Are you able to use it in certain situations where steel bearings, they wouldn't have thought to go as far as like manufacturing?
Exactly. Where you need more speed for grinding applications, for instance, when they want that surface foot increase, you know, for the grinding wheel, or small drilling, like in the printed circuit board applications, going to ceramics, give them more speed so that they can acquire that. But, you know, those are some good things for ceramic bearings, but there are some bad ones too.
Yeah. Well, what are the bad ones?
The bad ones, you know, again, the ball is very hard, which gives us some advantages.
Yep.
But let's put it into a situation where a spindle or a motor or whatever is rotating has an impact to it. Well, now that has a negative effect to the raceway. So suppose we're grinding an internal cam, for instance, where we're getting that interrupted cut. Well, now that ceramic ball is pounding on that steel bearing, and it being so hard actually acts as a detriment to the ball bearing versus where it was an advantage when it's, you know, nice and smooth and just running in a high-speed fashion. So as it is a better bearing, and it has its applications, which are a lot more than it has its detriments. There are some detriments of using a ceramic bearing over a steel bearing, and that is one of them.
Okay. Do people have to retool their machines for ceramic use as far as
No, there isn't really a lot of retrofit. The bearings and the bearing manufacturers have done a great job of using the same external raceway sizes and spacers and preloads. I mean, there are some things to be cognizant of. Another advantage of ceramic bearings is because the ball is light and so hard, and another thing that we didn't add is it's also resistant to higher temperatures. A lot less lubrication can be used too. So in low lubrication situations, it can also be advantageous.
Yeah.
And I know we're going to put a couple of charts on the wall here too as well that kind of show that centrifugal loading chart and what the advantages are, as well as some of the life extendency that you'll get out of a ceramic bearing versus steel. And typically what we're finding as results in the market is 2 to 3 times life out of a ceramic bearing in a solid environment that it belongs in versus a steel bearing is what we see.
So being able to run higher speeds, lower heat, does this, I'd mention this, be safer? I mean, are the machines themselves going to cool down significantly? All that
everything, vibration and energy, and vibration and things like that, and running smooth is all, by definition, vibration is wasted energy. So anything that's going to run smoother and faster is going to be safer. It's going to be better part finish for the consumer. And all those advantages will trend down. I mean, obviously with downtime these days, we talk about that in our vibration analysis program quite a bit, and the reliability stuff. If we can keep things running longer and machines aren't being brought down for service, obviously that's more productivity for the customer as well. So those advantages shine through as well.
And with metal, steel, I'd imagine electricity could flow through that. Does ceramic, does that block that?
Yeah, and ceramic is it's obviously metal conducts.
Yeah.
So if we have electrical charge, and there are spindles that actually use its chaff while they rotate to electrically discharge for metal removal in different applications. Well, with a ceramic bearing, we now have an insulation barrier between the inner and outer race, which gives us an insulation from the outer part of the spindle to the shaft of the spindle, because now we have that insulator between the two that before ceramic bearings came around, that didn't exist. So it's another benefit. Very, very well point out.
Very cool. Any other side benefits that we haven't talked about yet?
Nothing that comes to mind. We did one other test, which was sort of neat. I think it kind of proves the hardness that we spoke about a little earlier. I don't know if you can see this in the camera, but we actually put this to a hand grinder. Just your typical bench grinder, I guess. And you can see the 2 slots that it put in it very quickly. Well, this small bearing had the same exact torture test done to it. And it literally wipe your thumb across it, and it was like brand new.
Yeah, it was amazing, because the steel one, you see all these sparks flying off of it, and then the ceramic one's like, is it actually touching it?
Yeah, it almost looked like a fake test. But it's quite amazing, the durability of them. We, in the spindle rebuild end of things here at GTI, we take apart spindles where the actual raceways are completely disintegrated, and yet the balls of the bearings, the ceramic, are completely still intact, and you almost think you could reuse them. Not that you would, but you could almost reuse them in another brand new bearing. And is there
a reason you wouldn't for whatever?
Just impractical. They're producing them so cheap that and assembling a bearing needs to be done with heat and induction heaters and things like that you wouldn't want to reproduce that to try to really build your own bearing in our environment.
So the bearings themselves are the small part of the price compared to the building of the spindle.
Yeah, it wouldn't make economical sense. But there are companies which, these ceramic balls are fairly well manufactured now, because they've been done for about 15 years now. But what I was trying to point out is, a lot of people have made ceramic raceways, inner and outer, to run completely with no lubrication and things like that. And it can be done, and that technology's out there. But machining these machining ceramic or silicone nitride that we're talking about, you see how extremely hard that is.
Right.
Well, imagine how hard it is to machine, and it can only be ground in a lot
and
of
it has to be
circles.
really precise, because if, like, steel, you have a little leeway, I think, with heat and all that. Heating and cooling versus ceramic.
Right.
It's kind of what you get when you manufacture.
Not only that, the only thing that can cut through it, because it's so hard, is diamond. So, so to actually machining it, an outer raceway would just cost so much more money. It just doesn't become practical in our spindle applications. But there are several spindle applications where there is no other choice, because like in a food industry or something where no lubrication can survive, or very high temperatures where no lubrication would just burn off, those bearings are used and are manufactured, and they're completely ceramic, inner race, outer race, and even portions of the cage. So it's interesting from that end. So eventually, as manufacturing evolves and they become easier to cut through the silicone nitride, maybe we'll see more completely ceramic bearings, which would probably put people like GTI Spindle out of business, because the spindles would last a lifetime.
Longer,
complete ceramic. So
very cool.
That's the story.
And these things have been around about 15 years?
Yeah, the real entry was pretty much my entry into the business when ceramics started getting their notoriety, was about 20 years ago.
Okay.
20 years
So the cost must have, it started probably really high. Now
3 to 4 times the amount of a regular bearing, where now they're in line with a steel bearing.
Really?
Very, very, very close.
Okay.
Yeah. Still maybe a 10 or 20%, depending on what precision we're talking about, ABEC 5, 7, or 9, the prices range a little bit, but I would say they're within 10 to 30% of a steel bearing. So it's very economical to put ceramic bearings in spindles today, or any other application.
Yeah. And most bearing manufacturers will also offer this, or are there a select few that make these?
Nope. Pretty much most of the big precision, anybody making precision 7 and 9 bearings have a ceramic offering. All of them do.
Okay, great. And if you guys have questions at home, feel free to email in your questions. That'll be linked in the description as far as how you can do that. So thank you guys for watching, and do you have anything else to add before we leave?
No. Please visit us on the web, www.gtispindle.com, and we hope you tune into our podcast as we evolve into hopefully a lot more fun subjects as we go along.
Yeah, great. Thank you.
Bye now.